Hey, rookie data scientist. I need you to analyze some data. Yeah, sure. Like a CSV file? No problem. I've worked with those before. Actually, this data is an XLSX file. You can deal with that, right? XLSX? What? Excel files are probably one of the most commonly used files for data analysis. Now, usually in data analysis, we'll encounter CSV files, but today I want to focus on how we can do basic data analysis with Excel files. Let's not waste any time and get right into the code. Okay, so while I'm importing these dependencies, and these are usually the same dependencies or libraries that we use in almost every video, let me tell you a bit about the data. So we're going to be using rideshare data. And the goal is to take this rideshare data and be able to visualize and map out correlations between different columns of the data set like we would usually do just with this different file format. And that's really important, and a lot of people can get confused how to import Excel files, different sheets. So that's what we're going to be focusing on today, just being able to manipulate this different file format. All right, so the following libraries are obviously for data importing and also visualization. So data importing, it would be pandas. Visualization would be seaborn, matplotlib. And we're also going to need numpy. Okay. So as you see here, on the left side of my IDE, I already have my Excel file imported. Let me show you guys what this Excel data looks like. This is what our Excel data looks like here. And then this is one sheet, because in Excel you can have multiple sheets. If you see down here, we can have multiple sheets. So if I go to interest rate and home prices, this is a different sheet. So what we want to be able to do is access one of these sheets, manipulate it, maybe drop some NA columns. So we're going to get into all of that because it might be a little confusing when you first see this. Like, how can I deal with this data if it's in two different sheets? Do I use indices? Do I use some special function? So that's the real point of this video. How do we access this data, clean it up, and visualize it in a really nice and cool way? Okay, now that we have our dependencies, our libraries imported, it's time to start getting into how do we deal with our file. So what we're going to do is we have some variable called file name, and we'll assign that to the path of our file. Now you might be asking me, how do we get the path of our file within some directory? Well, if it's in the directory where your code is, all you have to do in PyCharm at least is, and in most IDEs, right click it and just select copy path. All right, and then you're gonna press copy absolute path. And that's what that's gonna allow you to do is directly call, we have to put this in single quotations. Oops. It's going to be able to let you directly access your file in PyCharm. So we have our file name here with its exact location. Okay, now what we're going to do is we're going to actually import this. We're going to introduce it to the environment. And so this is the most important line. We're importing our data. And we're going to be using pandas. So we'll create some variable called XLS, which is the shortening of XLSX, Excel's file. And we'll assign that to pd.excel file. And then our input will be file name. Now, what this has done is this has imported the Excel file as a whole. We want to see if this Excel data was totally foreign to us. What are the different sheets or sheet names within this Excel file. And the way we do this, we print the sheet names by saying our print function, and then we just do xls.sheetnames. And if we run, we get two sheet names, interest rate and home prices and transit demand. And our Excel file indeed has two different sheets with those corresponding names. Now, let's say we wanted to access individual sheets. How would we go about this? Well, we would take our Excel file and kind of call on one of the sheets, and we can call on them by name or by index. All right, so let's start by name. So we'll say sheet 1, and we can add a more descriptive name a little bit later. We'll say sheet 1 equals xls.parse interest rates and home prices. Okay? And so what this will do is it's accessing that particular sheet, and we can see what that outputs by just printing sheet 1. And if we print sheet 1, we get the first sheet. This is what it looks like. And to validate this, we'll open our Excel file and see if it corresponds. So if we look at our Excel file, here it is. Let's see if our output corresponds to what our Excel file actually looks like. And we see mortgage rate, and home prices at the top. We have a bunch of blank here, and then we have our X and Y variable, median home price, and then we have all of our values. It looks like there needs to be some data cleaning going on here, and we're going to get to that in a moment. But just from pure printing out the sheet, we can see that our output and reality corresponds. Okay? So now back to the code. We've printed our first sheet. Let's access our second sheet. Sheet 2 equals xls.parse. And again, if we go up here, we see that transit demand is the name of our second sheet. So we can just copy this in single quotations, just put transit demand and print that. And as you can see here, we've accessed the transit demand file. And this doesn't have any NaN entries or null entries except the last average entry. And we can fix this. So the way we check if some values in a data frame or a pandas data frame specifically is null is by saying our sheet, so sheet 2 dot is null. But we don't want to see if one column is null in the data. We want to see in every column how many rows are null entries. And the way we do this is we say is null dot sum. All right. And then what we can do is we can just print this out. And when we print this out, we see that in 3 of our columns, we have null entries. Population of city, monthly income of riders, and average parking rates per month. What we want to do is we want to drop or take away all of those null entries. So what we did here was sum up all the null entries within our Excel file. Now what we want to do is take those away because we want clean data that we can analyze. We don't want any null entries or empty entries. So the way we drop null entries is using dot drop NA. And this is another pandas data frame function that we can take advantage of. And you can see how powerful pandas is when it comes to data analysis and working with different file types. So we'll do sheet2 dot drop NA. Drop NA literally means drop all null entries. And then what we'll do is we'll print sheet2 dot is null sum and see what has changed. Okay. So now what we did was we assigned sheet2 to sheet2.dropNA and then print it out sheet2 and see how many null entries there are. And if we did drop NA, we see that there are no null entries. All right. And then to validate this, we can even print sheet2. And previously we saw null entries. And now you'll see we don't have that average with all the null entries in it. This is a completely clean data set. And even we can, I don't know, do sheet2.tail, which gives us the tail end of our data. Then we see that there's no empty entries here. And if we wanted to do .info, that also gives us different information about our data. So previously we had 28 entries, and now we have 27 entries because one of the entries contained a bunch of nulls in the row. All right, so that is how you drop null entries. Now, let's see if we can start graphing this data. Let's start trying to visualize this data. So one of the most important things in data is to look at the distribution of the data. So creating distribution plots is probably the most simple and essential way to visualize what your data actually looks like. So right now we're going to create distribution plots. And a good way to do this is we want to do it iteratively. We don't want to do this for every column. We're going to individually, manually input the names of the columns. It's better to do this iteratively because we can do this in one shot instead of manually entering the names of the columns. So the way we do this is we say for column in sheet2.columns. All right, so sheet2.columns, we can print that out to show you guys what that looks like. It's going to be basically a list of all the column names. So if we print that out, we're going to comment this out because it will give us an error if we don't. If we print that out, now we see all of these column names. So we're going to be comparing, we're going to be looking at the distribution of all these columns, all right, and seeing where the data is falling. So the way we do this is we can eliminate this print statement. And the way we do this is for column in sheet2.columns. Here comes Seaborn, sns.displot. We're calling the distribution plot function here. Now we're going to input our column name. So we're going to say sheet2.column. All right. Next, we're going to say how many bins are there. You're going to see in a distribution plot, there are going to be bins that classify within a certain range where's the data falling. All right. So just like a histogram, you have different bars. So where do the bars exist? Between what range do the bars exist? So bins is going to determine how the data is split up into chunk size pieces. And then we can also set the X label to the name of the column. All right, so we have an individualized kind of customized distribution plot with the name of the column with the count. And let's do a couple of things to make it a little bit better. We can say plot.title, and we can call the title the column plus distribution plot. And now what we can do is we can do plot.show, and this will allow us to showcase our plot. Plot.show. All right, let's run this and see what we got. All right, let's press run. So here we have our figure. All right, we have gotten some figure here. And this is a distribution plot. So this is of the different cities. Here, let's see another plot. We have another plot that tells us the distribution of weekly riders. Another plot that tells us the distribution of price per week. Another distribution of population of the cities. Another one that tells us a little bit about the monthly income of riders. Interesting. Parking rates. So this is the power of iteratively generating these distribution plots. We can quickly generate like 6, 7, 8 graphs based on the amount of columns we have. In this case, we have 5 columns, so we generated 5 graphs. But that shows you the power of doing this stuff iteratively. It makes it so much easier. Now, we created those distribution plots. Now I want to kind of see how the data interacts with itself. What are the correlations between the data columns? All right, so let's eliminate this little graph here and get back into the code. So now we want to visualize the correlation between columns within our data. And so the best way to do this is by using a heat map. And correlations really mean how are two columns or how are two variables connected. And we can quantify this. And so we want to create a heat map that shows correlations between columns. Creating a heat map is super simple. First, you'll need a variable called correlations, or whatever you want to call it. And you'll set that equal to sheet2.core. Then you need 2 more lines of code and you'll be able to output a heat map. sns.heatmap. And this takes many arguments. You can really customize this to your liking, but we're gonna just put in a few. So we obviously need to input correlations as one of the arguments. And it's going to be in a grid format. All right. You can customize the color map, and that's what I'm going to do here. I'm going to say color map or CMap equals yellow, green, blue. And I'm going to want to annotate the correlation. So I'm going to say annotate equals true. And you can add a bunch of stuff like line width and corresponding graphs that go on the heat map, but we're going to keep it super simple. So this is how we generate this heat map. And then, And then to show the graph, obviously we'll do plot.show. Let's see what our heat map looks like. So run the code. We have all of these graphs, all good. Let's see what this heat map looks like. All right, so this is our heat map. A little confusing, what does it mean? So let me make this slightly larger for you guys so you're able to see it in full. So the columns are really like text heavy, so you might not be able to see the entire column. But basically what you're seeing is the correlations between columns and themselves. And so you see a column in itself will have a correlation of 1 because it's 1 to 1. But we really want to see how data is correlated, because if we wanted to do, for example, classification problem or a regression problem, we'd know the correlation between different columns, and therefore we might know what columns to use to output some prediction. All right. So here we are, positive and negative correlations. You see this green, yellow, blue color map. Each cell in the grid is labeled with its custom annotated correlation. And so this is how we output a heat map. And this is really cool and super useful if you're doing more in-depth statistical analyses, as knowing the correlations between columns is really important when you're trying to attack a problem or trying to analyze the output of your code based on some data. And so now we have one last thing to do, and this is by far my favorite, creating scatterplots. So scatterplots are super fun, and the way you start out by setting up scatterplots is splitting your data up into feature variables and your target variable. So features are like all of the X inputs, and the target variable is the Y output. Since we're not actually implementing a classification problem or regression problem, we're just analyzing the data. This is kind of arbitrary, but I still want to show you how to split up your data into features and the target variable. So how do you do this? So you'll create some variable features. You want to know what your target variable is. In this case, this data is trying to predict the number of weekly riders based on the population of the city, based on the income of the riders, based on the weekly demand, things of that nature. And so the predicted variable, the target variable, is number of weekly riders. All right. So to create a variable that ignores that variable and includes every other variable, so including every X variable but ignoring the Y, we do sheet2.drop, and then we want to include the name of our Y variable, our target variable, number of weekly riders. And then axis equals 1 is kind of just like a location identifier. Target variable is our target variable, our Y. And so the way we access this is we just say sheet2, and then we just use the name of the column, number of weekly riders. All right. Now to create a graph of every feature against our target, we simply iterate through features and do like a versus, like feature 1 versus target, feature 2 versus target, feature 3 versus target, and so on. And the way we do this is for feature in features, so basically for columns in this set of columns, let's compare that column with the target. Apparently I spelled features wrong here. Let me change that. Okay, so how do we do this? We say sns.scatterplot. Now we need to fulfill a few arguments. We'll say data equals sheet2. We need to define our X, which is equal to our feature. And this will be different every iteration. And our Y is always the same. It's our target variable. And as always, we're trying to display some output, some graph, and so we do plot.show. Okay, now let's run this and see what our scatter plots look like. So here we are. Here are our scatter plots. So you can see number of weekly riders based on different cities, but more importantly, we want to see number of weekly riders versus the price per rideshare average per week. We also want to see the population of the city versus number of weekly riders. That makes sense. Like if you look at the graph, the higher the population, the more demand for rideshare services. What else can we see? The monthly income of the riders versus the number of weekly riders. So the lower the monthly income of the riders, the higher the number of weekly riders, which means that lower income individuals might be using rideshare services. And so you can see how we look at these different scatter plots and we can extract data, or we can make certain conclusions. That's what's so powerful of doing data analysis. Visualizing data is extremely insightful. And so doing it with other file types besides CSVs is super, super important. And so if you did enjoy this video, learn something from it, make sure to like and subscribe down below. I'd like to thank the sponsor of today's video, Datacamp. You might be asking, what the hell is Datacamp? Datacamp is how I learned data science and machine learning. It is a comprehensive course website that allows you to learn all about different topics within machine learning, data analysis, and even basic Python skills. I really recommend it. Make sure to click the link in my bio to learn more about how you can use Datacamp and their different price plans. If you want to see my comprehensive review of Datacamp, make sure to check out this video.